Okay, so I'm just going to open this up. If you have a question, raise your hand. I'm going to come and give you the mic. We're trying to get this all on recording everything. So if you've got a question, raise your hand. I'll come to you, and then we're going to give it back to any one of the speakers up front. So
I'll premise. I have two questions for Greg. Is a kite a UAV?
No, but kites have specific regulations, and I don't know the FAR part, but there are regulations for kites.
The other question is...
Let me answer it again now that you have the microphone.
Okay, sure.
Kites are not unmanned aircraft, but kites have FAA regulations that govern their use.
Okay. And facilities, like the room we're in, regulations for aircraft?
No. So the FAA is taking the position that operations indoors are not within the national airspace. But previously, publicly navigable airspace was largely thought to be above 500, that area above 500 feet, except for the area in which the airspace that was necessary for takeoff and landing, which for helicopters would extend all the way down to the ground. But the FAA has reinterpreted their position in light of unmanned aircraft. And so I have a post up on Forbes about this where I asked the FAA about it, and they said that publicly navigable airspace when it comes to drones is anywhere that a drone can operate. And so when a drone is taking off, it's on the ground. Once it's 1 millimeter off the ground, that's considered publicly navigable airspace and subject to the FAA's jurisdiction, which tees up a potential property law problem somewhere down the road where the FAA is going to basically, you can build a 150-foot tall grain silo on your land, but you can't fly a drone at 5 feet or 5 inches or 5 millimeters above your property. I foresee some sort of challenge to that coming down the road.
that's like the defining the waters of the U.S.
That's right. Yeah, just right. Like the puddles, right?
Yeah.
I mean,
Your bathtub.
right, under the Clean Water Act.
Right. Other questions?
Where do blimps or lighter than air craft fit into this?
Blimps and lighter than air aircraft also have their own set of regulations based on the cubic volume of lighter than air gas inside of the aircraft system and whether they're tethered or not, whether they're located within a certain distance of buildings and below the height of the buildings. And so when I went and gave a briefing to the White House prior to the FAA's regulations coming out, I had a briefing at the Office of Management and Budget, and I said, when it comes to drones, if they're operating below the height of a building and within a certain perimeter of the building or below the height of trees, wouldn't it make sense to treat them more like blimps or kites or other tethered aircraft because they're not presenting a risk to aircraft because no aircraft are going to be flying between trees or below building height. It didn't make its way into the regulations, but perhaps in the comment period someone will bring it up. But blimps and lighter than air aircraft also have their own set of regulations. I think I have too with the two strings and done tricks.
Let me make a comment on that since we have flown both kites and blimps on our campus. And of course, there is a FAA ruling with tethered blimps and kites, which is, I think, FAR 101. And so we had, like when all these rules came down, we had thought of putting little motors, propellers and motors so that it can cover a little larger area. But I think when we investigated, it sort of fell under the US ruling. So we could not sort of use that kind of creative, like what you are saying, with a blimp with a little propeller falls under the US ruling. So blimp tethered, no propulsion is fine. So it's as long as you put a NOTAM and all of those kind of things when you're flying below 400 feet.
I'm going to ask a question of this first speaker that we had this morning. So Ken had made a comment or had talked about plant-specific or leaf-specific management, and I might not be getting that entirely correct. But then our speaker I think Raj Khosla also talked about plant-specific, or maybe it was Yong-Lak. But anyway, this concept of managing the specific plant, and so in this conference it's IPM, but there's things related to that, whether it's nutrients, whether it's water. So, are we seeing, or is that a change that you see coming? I mean, are we going to be able to get to that level in our management in these large field situations?
That's a good question. I think we will get to those levels when the economics justify it. Because if we look at, for example, I think the example that I was showing was weed control very early season, and we know that that's when the competition from the weeds is particularly economically damaging. And if we have a ground-based vehicle that may be in there doing some other operation, for example, cultivating between the rows, so at that moment, what we have is a situation where we do have the potential for economic damage. We have a vehicle that's already there. We have the ability to sense, and we have the ability to take some actuation at that scale. Then I think the economics do drive plant-specific or least-specific agriculture at that scale. But it has to be a specialty crop or a crop with a high value where that pest problem presents some economic damage or potential economic damage. And it's economical to have that vehicle and that level, to have a tool and a sensor at that location at that time. And it is possible.
Are you familiar with the swarm technology? Have you seen that? So they have these robots kind of positioned within the field, and then they have their different areas that they manage.
Right.
And I know that's still kind of at the research phase, but that to me is indicating that that's a potential for this precision management.
Right. And so many of the issues related to the pest management are interrelated with other issues. If you have access to a source of labor that will go out and hoe weeds, then that becomes the economic bar. As that source of labor has other options that's more enjoyable, or compensation is better than hoeing weeds, then if we're going to produce those crops, and particularly if we're going to produce those crops in an organic fashion, then technology is really the only way we're going to be able to address that.
Yep, go ahead.
Precision ag, in its true sense, is managing individual plants, in my opinion. We did that long ago when there was nothing. When we were doing everything by hand, we're managing individual plants. And with technology, I think long-term goals should be towards that, to optimize or maximize the production out of cropping systems. Now, it varies between, we're talking about corn or apples. If it is apple tree, we're already doing a lot of individual tree, or we have capability to do individual tree level management. Whether we do that or not is, again, goes back to economics. So in terms of technology point of view, we can sense the parameters for individual trees, and we can change application rate, for example, based on what we sense for individual trees. We saw that some of the slides in our presentations too. With a lot of individual nozzle-based control for boom sprayers, if it is not individual corn plant, we are able to manage a few corn plants at a time technologically. But then there is a limitation of economics.
Can we also, so this conference is IPM, Integrated Pest Management. And typically, integrated pest management is you use one practice in one particular time. Whether that's rotating your crops, whether it's using a different treatment. And when we heard a lot of talk about, Raj talked about spatial and temporal. So can we actually do true IPM where we have those tools in the field at the time that we're going through the field. So if you're going through the field and you've got a weed problem, you've got all the tools on your system to address it and say it's resistant to something. Then the computer makes the decision to, okay, this is a cutting treatment. Or it identifies the weed as a perennial. Well, then we're going to have to do a different. So, can we get to that level? And this is, and anyone can respond to that kind of question too.
Probably most of that will be done, like since we are thinking of UAVs all the time, probably these will have to be done by ground robots. Most often than not, ground robots will be closer to the ground. And with the sensors they will have the resolution that we are talking about. With UAVs flying high, of course, defense has all that, already has all of these technologies, which is not going to be economically viable for agriculture. But technologies do exist, and possibly these technologies can be used in ground robots very effectively, closer to the ground.
I can talk about some comments about it. So we have to think this way. Integrated pest management is part of actually integrated crop management. So insect or disease or weeds itself is actually interacting with the environment as well as plants. So sometimes insects, the symptom by insect feeding and disease we cannot distinguish by using sensors. Sometimes it's hard to tell. I think it's one of our speakers talked about it. We see the problem, but we don't know that's done by insects or disease or nutrition or drought. So which means there's so much rooms we have to actually go through. If we don't have that, it will be very hard, as you said. When you walk through, we just use a robot or sensors or UAVs and detect something. It will be very hard to tell. It's depending on time specific, location specific, and variety specific. So it will be very hard, but we try to get there. That's
Right.
kind of our goal.
Ken, I think you mentioned the time. You talked about, was it 20 years before you actually saw something adopted into what you were talking about? Blue River and their technology
Right.
has been a very long period of time for that to actually make it to that level.
Yeah, we do see. I hope that we don't see that scale of time lag for some of the technologies that we see here, because a lot of these technologies are faster moving. And if we think back to when some of the initial work, the idea of a computer on a tractor was kind of radical at the time. Well, now you can't buy a tractor that doesn't have a network and a number of microprocessors running the vehicle. So the comfort level and the robustness with the electronics has certainly changed in that time period for that particular technology that we saw the example of. And also, I think the awareness of the ag community for integrating technology, much as the technology is integrated into their lives for other things, it integrates into the crop production too.
Right.
So I think one of the things that we're seeing on the delay, on the time lag for adoption is, if there's the bias towards the status quo is always present, right? And barring changes in the inputs to the labor cost or something else on the equation, change presents change presents risk. And so I'm an advisor for policy and technology to a consulting firm called Measure, and we just partnered with the American Farm Bureau on a 90-day project to do a study of the return on investment that comes from drones. And the idea is that if we can gather the empirical data to show whether drones help or don't help, that we can shift that timeline on adoption of technology, because the hardest barrier to overcome is to go to someone and say, well, how is that worth it, and what are the risks that are going to come? And so if you can have someone, like the American Farm Bureau come and say, well, here's what we've proven in those circumstances. And so one of the examples that we put into the research design is that in some use cases, you have many personnel whose responsibility is to walk the fields looking for things, right? And so one place that if you have an adequate enough sensor capability is that you might decrease the cost of the labor of walking the fields because the drone walks the field. We're not totally integrated, right? We as you mentioned, we won't know that that's an invasive species, or if there's a water problem or whatever. We might know the water problem, but in a specific spot, but we'll know the spot to send the person out to walk the field. In the wine context, vineyards now are at the point where they can identify which grapes need to be picked, plus or minus a day. So instead of doing an entire row, because of changes in geography, some grapes might need to be picked before others. You wouldn't do the whole row. You might do the first third and the last quarter, but not the parts in between. And so I think that as we gather that data, we'll start to get closer and closer to that integration point where we might even be able to have the ground robotics and other things.
One of the things we did a few years ago, looking at adoption of new technologies, we said, all right, let's go down to the basic level where things happen in ag, and we talked to the sales folks, the guys that go to the trade shows, that are in the booths, the guys that are actually closing deals on farm equipment. And at that time, some of the new technologies coming out were like auto steer and rate controllers on sprayers, and said, how do you make a sale to a grower? Typical grower out there. And granted, most of this was specialty crops. And they said, look, if I can show a buyer, a grower, that there's a reasonable payback in 2 years, I've got a chance of making a sale. If that, for a new technology, if the payback period is beginning to stretch beyond 2 years, it becomes hard for me to make that sale and to have that discussion with them. And so a lot of times when we're doing now our economic studies on the technology, we keep in mind, is this going to be a 2-year payback or not? And what is it going to take in terms of number of machines or number of acres to get a 2-year payback, so that when you go all the way through the process, the R&D and the filtering and the commercialization, that at that farm show where that salesman is making a sale to a grower, that there's a 2-year payback. And it's not a bad number. The number tends to come up a lot in industry, in the ag industry.
Great. Any other questions out here? Because I'm going to ask another one, if you guys don't.
I have a quick comment here. Yep. Like some of the farmers we have talked to, like I guess needs to talk to the lawyer here, because they're really very interested in just observing the fields with the UAVs, like even with DJI Phantom 2s and things of that nature, because what they're interested in, like sometimes deer damage and all of those kind of things, which somebody has to walk the field to figure out. So those kind of applications are not really very engineering driven or anything like that. It's just the farmer interested in flying his own field. But when he learns about Section 333 and all of those kind of things, he, of course, is a little intrepid about this. Like, he's a little scared about all this, so.
I have to be the Debbie Downer on this. So I was on a call. I can't say who the person was, obviously, but I was on a call the other day with one of our consulting clients who said that one of his competitors got a 333 exemption, and within a week, he got a phone call from the local FAA enforcement authority wondering why he was flying his drone on his field, because his competitor, because if you're wondering how that happens, right, all the 333 exemptions are public. So I can go in and I can know who has an exemption and who doesn't. And I said, I was like, no crap, buddy. Like, that's what I said to him. I said, this is a guy we were trying to convince to work with us. And I said, imagine you had a storefront or a restaurant, and you wanted to put up an awning, and the town told you couldn't. You could only put up umbrellas. And you put up umbrellas, and then your neighbor put up the awning. Wouldn't you call the city and say, why does that guy have an awning? I wanted an awning, and you said no. And that's what's going on. And so we're starting to find this thing. And then the fines and the certificate action are the type of thing that, if you're taking the long view, you have to factor in that maybe not in 2 years or 5 years, but 10 years from now, you might want an unmanned aircraft. And this is why I hate lawyers, by the way. This is why I'm not really a lawyer anymore, because the lawyers just take, right? We just suck off of like everyone's hard work. I'm like the Debbie Downer buzzkill guy at all these things because I'm telling you, I'm not the FAA though. I'm just telling you how bad they are. Anyway.
Great. So I'm going to shift it just a little bit here. When I've made presentations on automation and technology, and I've talked to students, I've talked to growers, and one of the questions is, I like sitting on my tractor in the field. I like doing that work. I don't want something replacing me. So, before I share what I say, have you gotten that response, or have you dealt with that? Someone maybe want to comment on that?
Well, more towards, let's talk about robotic apple harvesting. So I think it's in general applicable to those sentiments of people making comment, well, you are removing our job. I mean, where do we go if you mechanize or automate everything that happens in the field? So that we get that kind of questions all the times, particularly not with UAVs. I don't work a lot with UAVs, but I work quite a bit with apple harvesting, cherry harvesting, weed control, and those sort of really labor-intensive tasks. Now, the response have been in two areas. One is we're not replacing, but trying to fill the gap. So there is a difference. It's not replacing, but trying to fill the gaps. I want to emphasize that again.
You're assisting. I mean, you're providing a tool to assist them in their efforts.
That's another part of it. What I'm saying is that already growers are feeling they don't have enough hand labor. Even this year in the state of Washington, a lot of growers left some of their apples in the field, partly because there was not enough labor. But there are other sides of it. And for example, the cost, the revenue, or the price per pound they get, and things like that. But part of the problem is not having enough semi-skilled labor. So we want to fill that gap. The other side of it is that these kind of seasonal work is providing employment for 6 weeks for apple harvesting. And after that, towns and towns are dried up, and a lot of cultural, social issues. The reality, again, is that it is said more than 50%, oftentimes 70, 80% of the labor is undocumented migrant worker. Again, I'm not, you can't quote me on that, but I mean, there are some documents indicating that kind of, some research document itself indicating that kind of scenario. So if something happens in the immigration arena, our high-value crops may not be there anymore. So we want to look into future and develop technologies so that we can still produce fruit if there is no labor available to pick them or weed the crop. So that's some of the perspective we provide when those kind of questions are there.
And you're already organic systems already have to deal with labor issue. So in that way, and we've written some papers on that, but it's like a social acceptance. If you're in an organic system, it's often not, mechanization is not really highly desired or accepted to some degree. So can you put a robot in an organic production system using organic method, non-chemical methods to deal with some of these issues? I mean, so now we're in the social area of what is acceptable and what's not.
I get this question a lot when I talk about drones for inspecting infrastructure. So if you think your city has 4 people who typically go out and inspect bridges, and now you're going to send the drone out and be more efficient, the first reality is, as public sector unions are not going to allow those jobs to go away. But if we spread that out more broadly to the agricultural context, while the person might lose the pleasure of like riding in the tractor, right, and that we can't replace that emotional connection, I think in the short run, and maybe the other panelists have a different view on this, I think in the short run, 10 to 15 year picture, those jobs are just going to be reallocated because we're going to have a data analysis problem. So right now, when we go out with agricultural clients, they still have to look at the imagery and figure out what it is that they're seeing. We haven't created the machine reading and the software algorithms yet that can determine exactly what they're seeing. So someone has to analyze that data. And so it's really just a reallocation of the work from the task that before might not have been as skilled to asking that person to use their mind. And so I tell my students that, that job, you are not being replaced by a robot. That job is being replaced by a robot. And your brain, your creativity, your analytical ability is going to be reallocated to other tasks to be more efficient across the, whatever the enterprise is.
Right. Other opportunities. I mean, you're allowing people to do other things in addition to that thing that they really love, if that's, again, the emotional part of it. But
yeah, I think the comment is like, by talking to some of the farmers with our extension people, it turns out people who own small farms, like 100 acres and below, they have this passion for being close to the tractor and whatever you were commenting about. But the owners of, like in Midwest, like who own 20,000 acres or something like that, there is the connection, like the farmers, like people who are driving the tractors really don't own the farm. So in there, the automation is a lot more applicable than in the small farms where people are really very close to the agriculture. There, they will use the technology, yes, whatever is available, but they will be on the tractor themselves. Like you are saying, that they have this connection with the land, the small farms. And we don't really have the technology at this stage to make small farms profitable with these kind of technologies. So like Ken was saying, like after all, eventually it's about the profit, the farmer profit. And of course, sustainability issues are always talking about people, planet, and profit. So social, environmental, and the economic issues will be integrated. So
right. Question over here.
Stephen, just to add to that, I got a lot. I think probably this issue of technology adoption on a broader scale and how it offsets basically that role in society or availability of jobs in that role for society has probably been written on in depth. But I would guess, maybe a little tongue-in-cheek, but the rate at which regulation, at least in the U.S., is progressing for UAVs, there will be plenty of time for people to shift their focus. Unlike some of our, glyphosate traits, herbicide resistant traits in some of our crops have taken off like that, and there's been major offsets in hand labor, for example, which, might be a different track of job pool change than what we might be facing with UAVs.
Right. Any other questions out here? We've got time. So I just want to do one more. This is just kind of a broad question. So we've talked about the economics. Obviously, that's part of this picture. We just touched on the social, but the environmental part of this, I think that's one area of this precision application, this precision management that is equally as important. And unfortunately, the first thing we always think about is the economics. But there's the environment that's we're altering it based on what we're doing. And so I think, this is maybe just a comment, but if there's some thoughts on, how are we getting people to think, not necessarily economics, but also the environment with this kind of precision application or this precision approach that we're using. Is any thoughts on that, or we've got a thought from the audience? Good.
It's a question that I've been trying to find the words for, but it piggybacks on your question. So I'm listening to all of the more special the technologies you're talking about are kind of increasing microanalysis to fine point specific plant. And I'm wondering if in that direction, which is so far out of the gate, this is what's happening, if at some level we're taking our eyes off of actually the macro analysis and the health of a soil, of an area, of an overall farm, of a general environment, and its relationship to farm health and overall productivity. The question is that unavoidably one of the byproducts with so much focus on a microscopic analysis? Do we lose sight of the larger environment? It's kind of a sense, you might say, well, we have so much data and so information, there's no way that could possibly happen because we're going to know so much. And I'm just wondering, at some point, there's what are you looking at? What are you seeing? What questions are we asking? Does that make sense?
So I will possibly comment on that in the sense that I'm in the Delmarva Peninsula, which is right next to the Chesapeake Bay. So the farmers do not take to the environmental regulations by themselves. Like, the regulatory body has to do it. And then the farmers adapt to it if the profit motivations do not get in the way. So I guess I'll leave it to the lawyer here to address these aspects. But certainly, we drive the regulations through the government to an extent. And once these regulations are in place, that's when the farmers have to adapt, and we have to find technologies which will still make farming profitable under those regulations. So yes, some of the technologies that we talked about in my presentation, if you were there, the variable rate nitrogen application is driven by the fact that we do not want runoffs into the Chesapeake Bay. But whether or not those technologies can be adopted by farmers profitably is another thing. So our governor was saying at that stage that we are going to give tax subsidies to the farmer for adopting these technologies. So a lot of things have to happen together. Policies, so people, planet, profit, and policies have to be sort of integrated together to make these things happen.
He added a P to the sustainability policy.
Let's talk about policy. So, not having an opinion about what the normative worldview should be, let me just paint the way that we get to a normative view, sort of the world, which is that someone decides that we should care more about everything you've articulated or the broader impacts on the environment, and it does come through the regulatory process. And so while UAVs and other robotic technologies allow for precise measurement of what we are applying, they also allow for precise measurement of what has been done, which decreases the enforcement costs. And so here's one picture. Instead of sending out an environmental inspector randomly once a quarter, I may have the drone that flies out and does water samples all along the Chester River next to, sorry, I'm doing a Maryland reference, all along the river next to your farm on a weekly basis that gets precise counts of whatever is flowing into the river. And when we get certain triggers, that tells us to go out and do greater enforcement actions. So that's one possibility, just on the early monitoring for environmental enforcement. Another possibility is that we recognize that with the ability that because you can be more precise with what you're applying, some regulator at the state or federal level will say, therefore you should be more precise, and it will become a regulatory mandate. And we see this in all kinds of areas of the law, right? You can put airbags in cars. Now airbags are mandatory. And then it was passenger side and then side impact airbags. And the most recent one is that your hybrid car has to make a noise so that people in the pushing their shopping carts don't get injured. That was a new regulation that came down because it was possible to make so that whirring noise that a Prius makes, it doesn't actually make that on its own. It has a little microchip with a speaker to make that noise. And so what ends up happening is the can on measurement or the can on achieving greater efficiencies becomes the should or the must in the regulator's mind. And so that we might get there more quickly through tax subsidies that say that we're going to incentivize you to adopt this technology. But I don't. If I'm an environmentalist, that world is not far off to me. That world is, I look at all this stuff and I say, if you can do it, then you should do it. We actually see it on the battlefield, which is sort of, if you could use a drone to drop a bomb on someone in a precise way, you're not allowed to use the dumb bombs and the manned aircraft, is sort of the push that people are trying to do. And I'm just making a rough analogy there, but you could see the same type of thing applying in this regulatory environment.
So we're 5 or more minutes over time, and so I don't want to keep this going too long, but I think we're getting into some really good discussion that could go on even longer. But I'm going to cut that off, and again, I want to thank our speakers today who were able to come and present some really good information. Thanks to all of you who stayed. Be sure to fill out the evaluation. I was told to say that, so please do that. There's an evaluation piece for this session. But again, thank you, speakers, and thank you for a great session.